Now that you're confident in how to upload a part, let's dig into the results and machinability report that Toolpath creates for us. I'll use this sample plate part, which you can find on the parts page, so you can follow along with what I'm doing. Clicking on the part takes us to the summary tab, where we can immediately see the issues we may encounter. In the upper right hand corner, we see our machinability score, which tells us how much of our part can be machined with the selected tool library. We always aim for a score of 100%. Speaking of tool libraries, Toolpath ships with two standard cut configs. This is just a fancy name for a tool library configured to work with Toolpath. We have a starter cut config with a few tools. Think of these as tools in your tool changer, and a default cut config with 600 tools of varying lengths and diameters. Don't worry, we'll dig into cut configs more later in the series. Looking at this part with the default cut config, we get a machinability score of 100. But if we switch over to our starter cut config in this dropdown, we can see our score changes to 85. And now we have some features highlighted in red. On the right hand side in the summary tab, we get a lot of important information about our part. We can see the bounding box of the part and the required stock size, and can specify if we have threaded holes. Scrolling down, you see we have some orange warnings and red issues. The orange tells us that a deviation is occurring. Let's click on this pocket, number 7, which Toolpath highlights and shows us where a deviation is occurring. It's trying to use our smallest tool to machine the inside sharp corner. I can see there is a 2.6 thou deviation because of the sharp corner. I can also toggle the visibility on and off with this button. You can set up whatever minor and major deviation limits you'd like in preferences. If we hop over to my preferences, I have my minor deviations set for 1 thou and major for 5 thou. So in our example, Toolpath decided this feature was still machinable because it's within my deviation range. Before we jump back to our plate part, I want to show you the other things we can set up in preferences. We can set our preferred 3D controls based on what we're familiar with, specify our default unit of measurement, whether it be inches or millimeters, as well as our default cut config, so that when we upload a part, Toolpath will analyze the part with that cut config first. Let's hop over to the stock tab where we can set up our stock size. I've already set up some of these parameters for our shop needs. For oversized stock, I like to have about 30 thou of material in all directions. This ensures full cleanup of the part. For the rounding parameters, I assume the X direction is always the saw cut direction, and for a saw cut, I expect a variation of plus or minus 1/16 of an inch, so I round it up to a 1/16 of an inch. For Y and Z directions, I round up to a 1/4 of an inch, because most bar stock sizes come in 1/4 inch increments. This can be handy so you don't have to do the math in your head to make sure your part fits in a standard bar stock. Jumping back to our plate part, if I scroll down to the red issues, let's click on pocket number 3. Toolpath tells us that this pocket has an inner fillet radii smaller than our tool. The fillets were modeled at 35 thou, and the smallest tool we can use to machine that pocket depth is with our 1/8 inch end mill. So we need to get a smaller tool in our library, or ask the design engineer to increase the radius of those fillets. So that's the summary tab. It gives you a high-level overview of the issues you're going to run to on your part. Next, let's jump over to the Tools tab. Toolpath has decided to use 10 tools out of our 12 to machine this part. We can scroll down the list and click this drop-down arrow. This shows us the setup that the tool is used in, and by clicking on the setup, Toolpath highlights the features that the tool is used on. We can also click on the name of the tool, which opens a tool details window, giving us important information on that specific tool. In the Setup tab, Toolpath intelligently analyzes the part to determine the most efficient way to machine it in the fewest amount of setups. I like to turn on Show Machining Directions so I can see the associated features for each operation. This part looks like a 3 setup part, but Toolpath identifies it as 4 setups. Clicking on the 4th setup, I can see it's required for a single through hole. I don't have any drills set up in this library, but looks like I would need a 45 thou drill in this case. So let's say you look at this part and you say to yourself, well, that's all fine that Toolpath selected those setups, but I would really like my first setup to be the other direction. No problem. We can define our preferred first setup by jumping back to the Summary tab and clicking this Edit button. Now we'll click on this drop down and select Setup To, then Recalculate. Let's jump back to our Setups tab and we can see Toolpath has analyzed our part in the new setup direction we specified. We can also specify what tools out of our tool library we want Toolpath to use to analyze our part. This is perfect for when you might have broken a tool and need to use another tool in place of it. In our case, let's say that we can't use our 1/4" end mill. We'll jump to the Edit button on the Summary tab and search for our 1/4" end mill. We'll deselect the checkbox, telling Toolpath to ignore that tool, and then clicking Recalculate. Okay, so let's talk about the Strategy tab. Toolpath shows its homework by displaying the machining strategy before it's imported into CAM, consolidating all of our tools and operations for the fewest amount of tool changes. I can highlight each operation to see the features it will machine. Clicking this drop-down shows me all the parameters for each operation, including speeds, feeds, width of cut, depth of cut, material removal rate, and cycle time. What you see in the Strategy tab is a one-to-one duplicate of what you will see when it gets exported to Fusion. Last but not least, let's talk about the Estimate tab. We'll see a detailed breakdown for each setup, the associated features, machining time, and total cost per feature. The total cost is calculated based on your shop rate, which can be customized by building an estimate preset. Clicking on the pencil icon lets us create an estimate preset based on our shop rates, machining cost per minute, setup cost, and tool change time. At the bottom right, there's a breakdown estimate for the part with total cost. Adjusting the quantity affects the pie chart, updating the material and machining costs while setup cost remains the same. In the next video, we're going to take these results in Toolpath and export them to Fusion for CAM automation.